Is it possible that the elemental particles we see today are just a small subset of the possible particles, and that the current abundance of elemental particles is due to natural selection between particles at the beginning of the universe? I once heard an analogy with how scientists investigate physics. The analogy was with a clock. The universe is like having a clock that you can't open. You can observe the dial and describe with great precision the motions of the hands, but without being able to open the clock, the true mechanism is hidden. The traditional view of physics is that we cannot observe the mechanism of the universe. We can only measure the behaviors and create our own models. We are forever ignorant of the true mechanism that runs our universe. However, I believe there is a way to know something about the mechanism, or at least some of the properties that the mechanisms will have. My approach is to develop assumptions about the properties of the mechanism, and then to test those assumptions against what we observe in our own universe. The assumptions have consequences. If true, they constrain what our universe could look like. The primary assumption of this document is that the universe is computable in principle. It means that whatever mechanism is responsible for operating our universe, it isn't able to perform mathematically impossible tasks, such as processing an infinite number of calculations in a finite time, or storing an infinite amount of information. By making this assumption, we can make predictions about the restrictions the assumption would place on the mechanism. We can then compare the consequences expected by placing these restrictions on the mechanism with the observed properties of our universe. One consequence of the assumption of the universe being computable in principle is the restriction on infinities. The assumption that the universe is computable in principle means that there should not be an infinite set of processes to take place for a finite period of time. For example, if in order to calculate what will occur in the next second for the universe takes an infinite number of processes, the universe would not be able to be computed in principle. To disprove the assumption in our own universe, we need only to find an infinity which could cause the computability principle to be broken. So let's have a look at a few infinities that may break the computability principle. Is the universe infinite in size? The size of the universe can be described as the distance between the most remote objects within the universe. If you take any two objects and calculate their distance, it will always be finite. Therefore, regardless of the number of objects in the universe, it can never have an infinite size, as the set of the most remote two objects will always be finite, even if the set of objects itself is infinite. Therefore, we can know that the universe is not infinite in size, although it may be expanding or contracting. Is the mass in the universe infinite? If the universe were infinite in mass but finite in size, we would experience infinite density. Since this is not an observed fact, I believe that the universe is in fact filled with a finite amount of mass. Is scale infinite? If the scale of the universe were infinite, and that there was no limit to how small an object could be, then the information about its position would be infinite. This would break the computability principle, as the information about the position of any single particle or event would be impossible to use in a computation or to store. The easiest example of a finite scale universe is one in which each spatial dimension is discrete. Many computer simulations, such as Conway's Game of Life, use discrete space. However, it appears that our universe is somewhat more complex. In our universe, there is a relationship between position and momentum that act in such a way that limits the information in the system. While I have not created a simulation like this myself, I believe that the reason behind the uncertainty principle is to limit the information in the system about the position and the velocity in order to make the universe computable in principle. In effect, while the scale of the universe appears infinite, in fact position and momentum are tied together such that they are computable and represent finite information.